Imagine you own your home outright and rely on your monthly pension to get by. After decades of working, everything finally feels stable. Then a letter arrives from Service Canada. Your benefits are reduced or completely canceled. And suddenly, you owe thousands of dollars back. Not because you did anything wrong, but because of a decision involving your home that quietly triggered rules most Canadians do not even understand. And by the time you find out, the money is already gone. Imagine you are a Canadian homeowner who thought switching to clean energy was a responsible and financially sensible decision. Lower monthly bills, generous government grants, a smaller carbon footprint, and a home that would be worth more on the market because of the upgrades you made. You called the contractor. You filled out the grant application, you approved the quote, and then, somewhere between the installation invoice, the electrical panel upgrade bill, and the heating system that struggles to keep up on the coldest nights of a Manitoba winter, you realize that the transition you were sold and the transition you actually got are two completely different things. The government brochure promised a cleaner, cheaper future. What arrived was $15,000. A heat pump that loses efficiency at exactly the temperatures your city regularly hits in February, and a grant application that turned out to cover far less of the total project cost than you were led to believe. Welcome to the Canadian all-electric trap. The first thing every Canadian homeowner needs to understand clearly, because this is where fear and misinformation are spreading fastest, is the difference between what governments have actually done regarding natural gas in homes and what they have not done. There is no nationwide ban on natural gas in Canadian homes. As of 2025, the federal government has not legislated a prohibition on gas appliances in existing residential properties. Canadians who own homes with gas furnaces, gas water heaters, and gas stoves are not facing a legal requirement to rip them out on any fixed national timeline. If a neighbor, a contractor, or a social media post has told you otherwise, they are overstating the current policy reality by a significant margin. What is true, and what is moving considerably faster than most homeowners have registered, is a layered combination of municipal building code updates, provincial climate action plans, and new construction standards that are collectively shifting the conditions under which natural gas systems can be installed. The change is real. The timeline is accelerating, but it is being applied unevenly across the country in ways that depend entirely on where you live. British Columbia is the most advanced jurisdiction. Vancouver's zero-emissions building plan requires all new residential buildings permitted after 2022 to be built as zero-emission ready, which in practice means all electric heating is now the default for new construction in the city. New Westminster, Victoria, and a growing number of other BC municipalities have adopted equivalent requirements for new builds. The BC Energy Step Code sets progressively more stringent energy performance standards that make new gas installations increasingly difficult to justify on paper, even where they remain technically permitted. Ontario updated its building code in 2024 to require new homes to be constructed with electrical infrastructure sufficient to support future electrification, a panel readiness rule, rather than an outright gas prohibition. The City of Toronto has explored more aggressive restrictions, but has not implemented a ban on gas in existing homes as of early 2025. Quebec has moved to restrict new natural gas hookups in certain construction contexts, consistent with the province's abundant hydroelectricity supply and its formal climate plan. Commitments. Alberta and Saskatchewan have moved in the opposite direction, with provincial governments actively resisting federal clean energy mandates and maintaining strong policy support for continued natural gas use in residential and commercial buildings. The practical reality for the majority of Canadian homeowners in existing properties is this: You are not currently required by law to remove your gas appliances. But if you are replacing a major system that requires a building permit, undertaking a significant renovation, or purchasing a newly constructed home, in certain municipalities, the rules governing what you are permitted to install have changed, and they are continuing to change. The window in which a straightforward gas-for-gas appliance replacement is universally available, administratively simple, and fully permitted is narrowing in specific parts of the country, faster than most homeowners realize, until they are standing in front of a broken furnace in January looking for a straight answer. The federal government's primary financial instrument for encouraging residential electrification has been the Canada Greener Homes program. In its original form, the program offered grants of up to $5,000 for eligible energy efficiency improvements, including heat pump installation, alongside interest-free loans of up to $40,000 repayable over 10 years. It was widely promoted as making the transition to clean home heating genuinely accessible for ordinary Canadian families. In 2024, the federal government closed the Canada Greener Homes grant to new applicants, citing oversubscription and budget constraints. The loan component continued under a revised structure delivered through participating financial institutions. Provincial programs have offered additional support. British Columbia's Clean BC program has provided rebates of up to $6,000 for air source heat pumps and up to $11,000 for ground source systems in qualifying circumstances. Ontario utility-linked programs have offered heat pump incentives, though the amounts, delivery mechanisms, and eligibility criteria have shifted multiple times. Alberta's provincial support for residential electrification remains limited compared to British Columbia and Ontario. The problem is not that these programs are dishonest. The problem is a persistent and consequential gap between what the grant headline figure covers and what a properly executed all-electric retrofit actually costs, a gap that catches Canadian homeowners off guard consistently and at real financial scale. A standard air source heat pump installation in a Canadian home involves cost components that the advertised grant figure does not fully address. The heat pump unit itself, appropriately sized and rated for Canadian climate conditions, ranges from $4,000 to $10,000 depending on capacity and efficiency rating. Installation labor adds $2,000 to $4,000 on top of that. But for the majority of existing Canadian homes, particularly those built before 1990, the electrical panel does not have sufficient capacity to support a heat pump system. A panel upgrade from 100 amp to 200 amp service, which is the minimum recommended baseline for an all-electric home, costs $3,000 to $6,000 depending on the property configuration and the municipality. If the home also requires air sealing and insulation improvements to allow the heat pump to perform efficiently, improvements that the mandatory pre-retrofit energy audit will almost certainly recommend, those measures add a further $3,000 to $8,000 to the project total. The all-in cost for a properly executed, code-compliant transition from gas heating to heat pump heating in a typical existing Canadian home regularly lands between $14,000 and $25,000. The maximum combined federal and provincial grant support available in the most generous jurisdiction, British Columbia, might offset $8,000 to $11,000 of that figure for qualifying homeowners who navigate the application process correctly and whose projects meet all eligibility conditions at the time of application. In Ontario, the realistic offset is typically lower. In Alberta and Saskatchewan, provincial support for residential electrification is limited, and the economics depend heavily on local electricity pricing relative to natural gas. The homeowner who saw the government advertisement promising grants for clean home heating and assumed the transition would be largely covered is frequently facing an out-of-pocket cost of $8,000 to $15,000 after all available incentives have been applied. That is the gap between the policy promise and the household budget reality. And it is the gap that nobody in the grant promotion material pauses to explain clearly. Here is the technical dimension of the all-electric transition that provincial climate plans and federal grant marketing consistently underemphasize. And it is the one that matters most for the majority of Canadians living outside British Columbia's mild coastal climate. Heat pumps work by extracting heat energy from outdoor air and transferring it inside the home. The technology has improved dramatically over the past decade. Cold climate heat pumps, the category specifically recommended for Canadian residential applications, are now rated to maintain meaningful heating capacity at outdoor temperatures as low as -25 degrees Celsius or even -30 degrees Celsius. This is genuine technological progress, and the performance improvements are real. What requires careful reading in the performance specifications is the efficiency curve. A cold climate heat pump operating at -15 degrees Celsius delivers significantly less heat per unit of electricity consumed than the same unit operating at 0 degrees. The coefficient of performance, the ratio of heat output to electrical energy input, drops as outdoor temperatures fall. At the extreme cold temperatures that are routine across large portions of Alberta, Saskatchewan, Manitoba, Northern Ontario, and Quebec, during January and February, a heat pump's operating efficiency can decline to levels that make the cost comparison with natural gas considerably less favorable than it appears in the grant brochure, modeled on moderate temperature assumptions. Most reputable installers and all qualified energy advisors will tell you that a heat pump alone is not the recommended sole heating source for homes in Canada's coldest climate zones. The standard professional recommendation for existing Canadian homes in these regions is a hybrid system, a heat pump that manages the heating load efficiently down to a defined switchover temperature, typically somewhere between -15 and -20 degrees Celsius, at which point a backup heating source takes over to handle the extreme cold load. In homes that already have natural gas infrastructure, the most cost-effective and climate-appropriate hybrid configuration pairs the heat pump with a retained gas furnace as backup. This preserves the efficiency and cost advantage of the heat pump across the majority of the heating season, the days when outdoor temperatures are above the switchover threshold, while maintaining the reliability and raw heating capacity of gas during the weeks when temperatures drop to levels that challenge the heat pump's performance. The hybrid system is generally the most technically sound and economically rational solution for existing Canadian homes in cold climate zones. It is also the solution that does not eliminate gas from the home, and that creates a direct conflict with the most aggressive municipal electrification policies and grant program conditions that require full electrification as a condition of maximum rebate eligibility. The homeowner who follows those policy incentives toward full electrification in a climate zone where a hybrid system would serve them better can end up with a system that underperforms on the coldest days, costs more to operate than projected, and leaves them questioning a decision they were financially incentivized to make without adequate technical guidance. The single most consistently underestimated cost component in Canadian residential electrification projects is the electrical infrastructure upgrade, and it is the cost item that most reliably transforms a manageable project budget into a financial shock. The average Canadian home built before 1990 was designed around a gas primary energy model. Space heating, domestic water heating, and cooking were delivered by gas. The electrical service was sized accordingly, typically 100 amp panel capacity, sometimes 60 amp in older properties, sufficient for lighting, standard appliances, and the electrical loads that existed in the era when the home was built. A 100 amp panel cannot simultaneously and safely support a heat pump system, an electric hot water heater, an electric vehicle charger, and an induction cooking range. An all-electric home requires 200 amp service as a functional minimum, and some configurations benefit from higher capacity still. The panel upgrade from 100 amp to 200 amp service costs $3,000 to $6,000 in most Canadian cities for a property where the electrical entry point is accessible and the existing wiring is in reasonable condition. In older homes, where the panel upgrade reveals knob and tube wiring, deteriorated aluminum branch circuit wiring, or other conditions that do not meet current electrical code, the scope of work expands significantly. In dense urban neighborhoods, where the service connection from the street involves utility company coordination and potentially infrastructure work beyond the property line, costs for the electrical service upgrade alone can reach $8,000 to $12,000 before a single piece of heating equipment has been purchased. Knob and tube issues often trigger major rewiring. This cost is routinely absent from the initial installation quote the homeowner receives. The heating and cooling contractor prices the heat pump equipment and the air handling components. They note in passing that an electrician will need to assess the panel. The homeowner interprets this as a routine administrative step. The electrician arrives, opens the panel, and delivers a written quote that is frequently the second largest number the homeowner encounters in the entire project, arriving after the commitment to proceed has already been made. Grant programs in most provinces include electrical panel upgrades as eligible expenses under certain conditions. The Canada Greener Homes Loan can be applied to electrical infrastructure work when it is documented as part of a broader retrofit project and included in the pre-retrofit energy audit scope. But the administrative requirement to include the electrical upgrade in the original project documentation, have it assessed in the energy audit, and apply for combined approval is a multi-step process that many homeowners, particularly those who began the project reactively in response to a failed appliance, do not successfully navigate. Too often, they end up bearing the full electrical upgrade cost out of pocket while qualifying for grant support only on the heat pump equipment itself. The final and most consequential dimension of the Canadian all-electric trap is one that policy frameworks and contractor incentives both avoid acknowledging openly. Not every existing Canadian home is thermally ready for full electrification. Installing a heat pump in a home with inadequate insulation and significant air leakage produces poor performance, high operating costs, and a homeowner experience that discredits the technology through no fault of the technology itself. A heat pump's efficiency advantage over gas heating is fundamentally dependent on the home's ability to retain the heat the system produces. A well-insulated, properly air-sealed home with modern windows loses heat slowly. The heat pump maintains comfortable indoor temperatures across a wide range of outdoor conditions without running at maximum capacity continuously. Its efficiency advantage over gas is real, and the operating cost savings accumulate meaningfully over time. A poorly insulated 1960s bungalow with minimal attic insulation, original single-pane windows, and significant air leakage around penetrations, electrical outlets, and the building envelope loses heat rapidly. The heat pump runs at or near maximum capacity on cold days and still struggles to maintain the set temperature. Operating costs are high. Comfort is inconsistent. The homeowner's experience of electrification is negative and expensive, and it spreads through neighborhoods and online communities as evidence that heat pumps do not work in Canadian winters. That is the wrong conclusion drawn from the right observation about a poorly sequenced project. The correct sequencing for a Canadian home electrification project, the sequence that reputable energy advisors, the federal government's own EnerGuide assessment framework, and the Greener Homes Program guidelines all recommend, is envelope improvements first, and heating system replacement second. Insulate the attic to current code standards. Air seal the building envelope. Address window performance where the budget allows. Then install the heat pump into a home that is thermally prepared to work with the system efficiently. The total cost of this correctly sequenced, fully executed approach, including attic insulation, air sealing, panel upgrade, and heat pump installation, routinely reaches $25,000 to $40,000 for a typical existing Canadian home. The available grant and loan support, even in the most generous provincial programs, covers a meaningful but partial share of that figure. The remainder represents the homeowner's capital investment, recovered over years of reduced energy bills at a payback period that depends heavily on the relative price of electricity versus natural gas in their specific province, a ratio that varies enormously across the country and is not within the individual homeowner's control. In provinces where electricity is cheap and abundant, British Columbia and Quebec above all, the economics of full electrification are genuinely compelling for well-prepared homes. In provinces where electricity is priced at or above natural gas on an equivalent energy basis, the financial case is more nuanced and requires careful modeling of the specific home's energy consumption profile before a confident recommendation can be made. If you found this interesting, check out this video here.